Alrighty, so you have just collected some data that shows you that temperatures decrease as you go higher into the atmosphere. So go ahead and add that as your first science idea on your packet. And then we need to ask why, because it's if we're going higher in the altitude, we're getting closer to the sun, right? So how is it that we are losing temperature as we go higher? So let's talk about it. So our atmosphere is made up of molecules of gases. The majority is nitrogen. Oh, geez. Majority is nitrogen. About 78% of our atmosphere is nitrogen. About 21% is oxygen, and the rest is made up of other stuff, including carbon dioxide, argon, a whole list of things in very small quantities. So at sea level, down here at the surface, the air, there are more molecules. And as you go higher, the amount of total molecules decreases. But notice on these diagrams that the percentages of the gases don't change. So even if you go to the top of Mount Everest and the air is very thin up there, it still has the same percentage of nitrogen to oxygen to the other gases. All right, so why are there fewer molecules as you go higher? And you've probably heard the word thinner with respect to the atmosphere. So the air, as you go higher, the air gets thinner, like up in an airplane or up in the mountains, the air is thinner. And that is because molecules have mass, even molecules of gas, and we know that gravity pulls on things with mass. So gravity of the planet is pulling the majority of the molecules down towards the surface. So that's why there are more molecules down low and fewer as you go higher. And as we sort of looked at in that last time we looked at this image, what we're talking about is density, really. So the number of molecules in the amount of space is greater down here near the surface and decreases as you go higher. Okay, so a little quick overview of our atmosphere. Our atmosphere is layered, and these are the names of the major layers. So the troposphere is the atmosphere down here at the surface. This is where we live. You go up into the stratosphere. Planes, if you go on a long flight, will just get up into the stratosphere a little bit. The mesosphere, and then the thermosphere. And to give you some, let's see, some elevations, the troposphere goes up to about 10 kilometers. I am really not doing well with these today, 10 kilometers. And the top of the thermosphere, I'm just looking at my notes here to make sure I get it about right, is about 500 kilometers. And if you, when you were doing your poster of the Earth's layers and convection and all that, if you took the little challenge to add the International Space Station to your diagram, maybe you remember that the ISS orbits at about 400 kilometers. So actually the ISS technically isn't in space, if you want to think about it. That is still up there in the very tip top of our atmosphere, although there are so few molecules of gas up there that they're few and far between. So the troposphere is what we are talking about. Cat is on my lap. Because this is where all weather happens, because it's where the moisture is. So as you go up beyond the troposphere, you no longer are dealing with weather, so we won't be talking about any higher than that because this is the weather unit. The other interesting fact is that, because we're talking about the mass of the molecules that make up the atmosphere, and we talked about the fact that gravity keeps them down low. And in fact, in the troposphere, if you go by mass, the number I found, about 75% of the entire mass of our atmosphere is down here in the troposphere. So that's another way to look at how many more molecules there are down here lower. Okay, so here we are with a little diagram. The little emojis here are meant to represent molecules of air. And you can see that there are more of them down low, fewer of them up high. And we were just talking about that in terms of density. And the word we need to introduce now is pressure. Atmospheric pressure is how we talk about density of the gases when we're talking about the atmosphere. So we talk about high pressure down here, low to the surface, and the pressure gets lower as you go higher. And this is why, sorry, I'm trying to make it so we can actually see what's going on here. This is the answer to our question about the temperature. So temperature is a measure of the average kinetic energy of the molecules in a substance. So higher in the atmosphere, there are fewer molecules, so the temperature is lower. So yes, higher in the atmosphere is closer to the sun, but there are fewer molecules up there to have the kinetic energy that is temperature. So that is why it is warmer down lower and cooler up higher.